In the thermos bottle, there is 230 gram coffee at 90 degrees Celsius. If it added by milk with amount 200 gram at 5 degrees Celsius, and it is considered that there is no heat absorbed by the thermos bottle, determine the temperature of the mixture.
Okay, first, we should suppose the coffee by number 1 and the milk by number 2. And we put the mix 1 or the mix of coffee by number 230 gram and the milk 200 gram. And the temperature 1 is 90 degrees Celsius and the temperature of milk is 5 degrees Celsius. As we know, the coffee has bigger temperature than milk, so it will release heat, and the milk, because the temperature is smaller, it will receive the heat. So to answer these questions, we will use Asas-Blake formula. Asas-Blake formula state that release heat will be equal to receive heat. And the formula is M1 times C1 times delta Ty is equal to mass 2 times C2 and delta T2. And the mass 1 is 230 gram, C2 is 1 calorie per gram degree Celsius, and the temperature 2 is T1 minus Tc. Tc means the temperature of the mixture that we will search. And mass 1, 200 gram, C2 1, and the delta T2 is Tc minus T2 because the T2 is smaller and will receive calor. As we know that T1 is 90 degree and T2 is 5 degrees Celsius. We times it together. After that, we put it closer at the same time, I mean Tc with Tc, and we will got the answer. We got that Tc or temperature of mixture is 50.46 degrees Celsius. Thank you. Okay, for the next question is about kinetic gas theory. The question is, oxygen gas has a mass of 64 gram and temperature 27 degrees Celsius. If the relative molecular mass of oxygen is 32 gram per mole, determine the inner energy of oxygen. Okay, to answer these questions, we should write the noun from the questions. It means of atom that it is 64 gram and the temperature is 27 degrees Celsius. We must convert it to the Kelvin by add 273 and it will become 300 Kelvin. And next is the molecular mass is 32 gram per mole. And as we know, oxygen is a diatomic atom. So to search the inner energy of diatomic atom, we use U equal to 3 per 2 times N times R and times T. N or number of mole we can use from mass divided by molecular mass, and R is a statute that is stated by number 8.314, and we times it also with the temperature. Okay, as we know that 64 divided by 32 is 2, and we times it together. And finally, we got the answer is 7,482.6 joules.